Welcome back. This is lesson 15 and a most exciting topic to talk about today. Don't go away. This is about sanding. Sorry about that, but we need to cover it. And it's not going to take a long time, so stick with me here for a few minutes. I want to talk about the different kinds of materials that we can use in turning. Now, sanding, buffing, polishing, grinding, all use the same kind of abrasives in different ways, but I'm going to focus only on things that we would use on the lathe. So let's talk about the kinds of sandpaper that we have and we start to work with. The least expensive, when you go to the hardware store, is to come up with what's called garnet paper. This is inexpensive. It doesn't last very long. It breaks down very, very easily. And in sheet form like this, it's pretty difficult for us to manipulate around something that is round. What we use most frequently is called aluminum oxide. This is one particular brand, aluminum oxide, marked on the back. It tells you what the grit is, how fine it is, and so on. What's interesting is this is also aluminum oxide. Color's different. This is called serrated, which means it has been prepared with a lubricant added, and the grits of the paper are farther apart from each other, both of which contribute to the ability of this paper to remove material from your product and not clog up. In fact, if you turn it over and read on the back, it says this is 180 grit. SC means this is silicon carbide, lubricated paper. And it actually says open, which means it's an open grit. So most papers are pretty well marked. Some are not as well, but most are pretty well marked. So we have the sheets. Here is a different kind of backing. Instead of a paper, this has a mylar back on it. Mylar meaning it's a plastic back. And because it's plastic, it means it's suitable for wet-dry applications. In other words, you can sand with water, with lubricants, with finish, depending on what your technique is going to be. But the back, being a mylar, will not break down. So you can look for papers that have mylar back. This is from 3M. The interesting thing is, when I look at the label, it tells me what the mesh size is, but it doesn't tell me what the grit is. So there's a relation between micron size, particle size, mesh, the grit through which the particles are sieved, and particle size, which is what we call grit. There's a relationship between those three, and believe it or not, the mesh and the grit are very close to being the same. So if you pick up some paper that says 240 mesh, know that that's approximately 240 grit. That's the size of the particle that went through that mesh. Grit and mesh refers to the number of holes in a 1-inch square. If it's 80 holes fit in that 1-inch square, you'll get 80 grit through it. There's 240 holes in that same 1-inch square. Guess what? It's a 240 grit paper. We have it both in plain back. We also have it like this. This is what's called PSA, or pressure sensitive adhesive. This is a different material again. This is called Norzon, or chromium oxide paper. This is much more rigid than the aluminum oxide, and it's better for use where there is higher heat. Used a lot in metalworking, but also used a lot in woodworking because it breaks down even slower than the aluminum oxide. Pressure sensitive means you clear off your disc, you peel off this plastic, and it sticks like Scotch tape. It stays nice and flat. One thing about this, as you use it, you need to constantly keep cleaning it. This is almost like a eraser on your pencil. Use it, rub this on it, it takes the wood particles out of the silicon carbide and leaves it fresh for the next time you use it. If you don't clean it, they'll fail much, much more rapidly. So we've seen sheets, we've seen discs. It also comes in rolls. Most times you see it on rolls, this is on a cloth back. Paper back, cloth back, mylar back. Cloth back has a different weight system. Trust me on this one. This is pretty stiff. This is called X-weight plate paper, X-weight cloth. Much more flexible. This is called J-flex, J-weight. And if you see on these cloth rolls, P180J. I know this is 180 grit. P meaning it's the European measuring system. Very similar to the US system, but slightly different. If you follow the P series as you sand from 80 to 120 to 240, you will be progressing in the natural order of things, same as you would with the US system, no P. The US, Europe uses different systems. Russia, Japan, many countries have unusually different systems for measuring the same things. J weight meaning it's very flexible, and many times we use rolls and strips like this when we're sanding, specifically around spindles on a project. Color doesn't matter. Another J weight, 80 grit, different brand, different color. So you can't use the colors as a code. A lot of these used. These are very small, hook and loop, Velcro backed papers. When they print them out in a box like this, most of them have the grit marked on the back. Occasionally when they punch this out, you'll find one that has nothing on it. And I actually go through and write on the back of each one of these so I remember what they are. This is a 2-inch PSA, and I'm going to talk about how these are used. I'm going to step over to the left a little bit and show you some of the ways that these are used in sanding on the lathe. So I'll be right back. Well, I slid over a little bit because I wanted to show you some of the devices that we use to run sandpaper against our projects. First of all, I did tell you about these rolls. You know how flexible they are. For spindle work, this is great. So you just simply cut off a piece the right length, hold it like a shoe shine rag over your product, keeping it moving all the time so the scratches are randomized, and move on. A lot of times we do various forms of power sanding inside a bowl, outside a bowl, on spindles. And we use these little discs like I just showed you a minute ago. If I'm doing something like a natural edge bowl where I have wings that need to be treated separately, I may use a power sander sort of like this. This is just a power drill. It has one of these inserted into the tip, and it can be rotated forward or in reverse to randomize the pattern of scratches even more. There's a trick to using these effectively. If I just stick sandpaper right on here and I crank the speed up and start to sand, one of the things happens is the surface and the sandpaper and the Velcro hooks here all get warm. The warmer it gets, the more of these little plastic hooks want to break down. And eventually this paper won't stick anymore. If you can hear that, that's this cloth back hooking into those little Velcro hooks. Prevent that problem, I suggest you go to your woodworking dealer and buy an intermediate pad of some type which then just sticks on here. The sandpaper goes on that, and if it wears out, you throw that away and get a new pad. You haven't wasted the money you spent on a nice sanding fixture. This one is fairly soft, it's thick, it gives me a lot of flex around an inside curve. This manual one is also a soft one. This manual one is a little thicker, a little stiffer, excuse me, because the foam pad in between is thinner. So, powered, it's one way. And these devices are all called reciprocal or inertial sanders. You hold this up against the wood, edge of this against your product, and as the product spins, this rotates the opposite direction. It randomizes the scratch pattern. It spreads out the heat. Put a sanding disc on there. And this particular brand is one I have. Here's another brand, same thing. They have ball bearing systems in here that allows this to spin freely. Here's an even smaller one, ball bearing system. So in each case, I have applied an intermediate pad in between. There are two different kinds of discs that we routinely get. Smooth edged, and there's this one with the flowered shaped edge. The thought is that as this one is applied these edges fall over and is less likely to cut into the surface of the product as you sand. This one, the thought is that there's a possibility that this edge could catch on the product and leave a deeper scratch. I haven't found that to be the case, but that is the marketing concept. They come in 3-inch size, which I don't have, 2-inch size, which I have many of, as you can see, and even in a 1-inch size. Little foam pad on this thing. So if you hit really small things, you can switch to a very small one. Sandpaper, sanding discs, inertial sanding, whether it's done by the power or done by just the inertia of the turning product. I have a problem in trying to understand some of this stuff myself, so I have gone onto the web and found information that relates grit, European system, American system, mesh, and so on, all in a chart. And this will be posted at the end of this presentation for you to be able to see and download. It'll also be available on my website. It's useful to have something to refer to like that. The weights of papers, A, B, C, D, E, F, and paper is fine. I can tell A is soft and K is hard. In cloth backed, we know J is the softest and X is the hardest, but the letter mixture in between seems somewhat random, so you need a table for that one also. I'm going to reset one more time, and I'm going to show you other ways of smoothing the surface of your product without using, quote, sandpaper. Other things that do the same job. So I'm going to slip to the far end of the table and reset one more time. Be right back. I want to talk about other ways of smoothing the surface of our wood products prior to putting on a top coat. And one of the things that's used a lot is what's called Abranet. It's made by a company called Mirka, and this is a polyamide matrix onto which the aggressive material is bonded. And it comes in all sorts of, quote, grits, P400 down to 180, 120, and so on. The thing that makes this unique is it's an open grit. I can see you through there. You can't see me through there. Sorry about that. The point is that as you sand with this, the sawdust passes through the paper and doesn't clog. And the Mirka company says that this then represents a way of keeping the paper cool while sanding and keeping it free from clogs. Each one of these is an open grit of polyamide with the bonded material to it. Apranet. They also make it for industrial use. This is one that's very similar, picked up after that. This is silicon carbide bonded to an open mesh in different grits, 120, 180, and 320 I happen to have in this particular set. This also works, but the backing is a little stiffer, and our students here in class don't particularly care for this as much as they do for the Apranet. Set that aside for a second. One of the other things we use a lot is what's called micromesh. Micromesh has its own measurement system, doesn't relate to grit and mesh as much, but we do know that we start with 1500 and go up at higher numbers, 3500, 6000, up to 12,000, and we run these in numerical sequence also. This is a material that goes to very, very high polish, I would say over 4,000 grit, and it's used a lot on plastics, final finishes, CA finishes on pens, and so on. It's available in sheets like this, marked each one on the back. It's available in squares. I got this set a long time ago, and you might not be able to see it, but the numbers are stamped on each of these. More frequently now, people are buying this. Here's the same set, color-coded, so that you can tell what the number is by looking at the color of it. The reason is we get them out of order. Second reason is after I'm done using these, I'm going to go in with soap and water and wash these. They are washable and then can be reused over and over again. These look like they need a little washing right now. It's actually even available in sticks like this for other small products. Very fine on this side, a little coarser on this side. Micromesh, available in the sheets, which are probably less useful for turners. These It's also available in rounds that could be put on those reciprocal sanders and manipulated that way, but used mostly for what we call wet sanding. In other words, a solvent or lubricant of some sort is used to help clear the chafe away as we work. So we'd wet these in generally water or a solvent, wipe down the product, go to the next color, and so on. Micromesh. Last thing I want to talk about, we also use a lot of, and I have a chart for this one too. This is from 3M. And these are called Scotch-Brite pads. I know you've seen the white ones in your home, in your kitchen for cleaning pots and pans. That is one of the Scotch-Brite pads with the finest of abrasive surface, perfect for cleaning. Now I have a chart here. This also is going to be in the end of the presentation. It shows the various colors and the relative grit for each of these. So we can go from something like 120, which is a gray, 360, 800, and the white one is around 1200 to 1500 grit. So if you're cleaning in the kitchen or wiping down porcelain, you're not going to leave major scratches. It's available in sheets, which can be purchased like this. I buy them by a box of sheets like this, take scissors and cut them into smaller pieces. Here's two different ones, coarser, slightly finer. The answer is on the sheet here, also printed on the box when I got them. The other interesting thing about that, 3M also makes them in bowl brushes like this. These can be put on the drill, power drill, run down inside of a bowl, and each of these pieces then will finish up your sanding. I understand people in the carving community also use these to smooth out the features on carved products. So basically what we've done in a short period of time is give you a quick overview of some of the ways of perfecting the surface of the wood prior to putting a top coat on and closing up the work. Biggest difficulties we find with our students and sanding is the inability to get all the scratches out at one grit before going on to the next grit. And as you go to finer and finer and finer grits, the original scratches become more and more visible, and the students will come and say, where'd those scratches just come from? It was due to the fact that they did not adequately sand at each grit before moving on. So the thing about prepping the wood for final finishing is take your time. It takes longer than you may think. And if you want a beautiful product to share with others, spend the time, find the right product wherever it may be, and do a great job. See you in the next video. Forgot something. Forgot to tell you about steel wool. And what's important to know about steel wool, it doesn't scratch like sandpaper does. Sandpaper is a bunch of rocks digging smaller and smaller scratches until you can't see them. Steel wool is like a whole bunch of very small planes slicing across the surface of the wood. It's a great way to finish up. There are a couple of brands on the market, but if you buy them from a woodworking dealer, that's where you want to go, because those that come from there are made without use of any oil products that won't mess up your finish or your wood surface. Those you buy at the hardware store are not reliable in that sense. They come in 1/0, 2/0, 3/0, and 4/0, and we generally in classroom use what's called 4/0 steel wool. Very fine, very smooth. 4/0 is equivalent to 400 grit, pretty close. So 3/0, guess what, roughly 300 grit, and so on. So if you sand up to 400 or 600 and then go to steel wool to complete your surface, you'll take most of those fine scratches out and plane the surface down. This can be cut off with scissors, and when you use it, you fold the ends in, because these little tiny fibers can catch on the wood and jerk that right out of your fingers otherwise. So fold it, use this as your final before you go to your finish. When you put finish on, sometimes you end up with a few little dust bunnies landing out of the air before it dries totally, and you'll end up with a few little bumps. Good thing to use steel wool between coats of finish at the very end to re-level the surface between each one. Forgot about the steel wool. Key product for me to use and for you to use. See you later.